In this video, we're looking at using StatCrunch and some of the calculators that are built into the program, and we're working with discrete random variables. So the first problem I'm going to work on says the accompanying table lists probabilities for the corresponding numbers of unlicensed software packages when 4 software packages are randomly selected in China. So we have a table with a random variable x, which is the number of unlicensed software packages, and it ranges in value from 0 to 4. And there's the associated probability. So the first question is this a random variable? So it is a random variable because the outcomes are numerical. They run from 0 to 4. And is it discrete or continuous? It's discrete because the outcomes are discrete numbers. And then does it show a probability distribution? And for it to show a probability distribution, there were 3 requirements. We have to have the numerical outcome, which we have for the random variable. And the sum of the probabilities for the outcomes has to equal 1. And if you check on your calculator here, you'll find that this actually adds up to a little bit tiny bit more than 1.001, which is fine. And then each of the individual probabilities for the various outcomes has to be between 0 and 1, and that's true in this case. And we want to find the mean and the standard deviation for the random variable x. So I went ahead and I put this into a StatCrunch worksheet, which I've got right here. Pull it side by side here. And so I put in the values for x and I put in the probabilities. And in order to find the mean and standard deviation in StatCrunch, what you're going to do is you're going to go to Stat, Calculator, and go all the way down to the bottom, and we use what's called a custom calculator. And you're going to pick first the values for the random variable. What values can the random variable take on? And I put those in the column labeled x. And then the weights, which are the probabilities, are in the column labeled p of x. And then I just hit compute. And down below here, here's my mean, and usually we round off to 1 more decimal place than was in the original values for the random variable. So we would get 2.8, and the standard deviation, again, round off to 1 decimal, we get 0.9. So that's the use of a calculator called a custom calculator, and you can use that to find mean and standard deviation for discrete random variables. All right, let's take a look now at a binomial problem. So when we have a binomial discrete random variable, we're going to use a binomial calculator. So in this problem, we have Consumer Reports survey, 39% of likely voters would be likely to vote by internet instead of in person. We assume that we picked 15 likely voters. So we're going to use that binomial calculator tool, and you need to know the sample size n, the probability of success p, and the number of successes we're interested in. So our sample size is going to be 15. We're going to pick 15 voters. The probability of success here is that the voter would be likely to prefer to vote by internet, so that's going to be 0.39, and we're looking first for exactly 3 successes, so our x is going to be 3. So again, I'm going to go over to this StatCrunch worksheet, and this time I don't have to enter any data in because I'm just going to use a calculator. I'm going to go to Stat Calculator, and it's called Binomial. And so what you need to enter in here is n, and we said we were going to be picking 15 likely voters. And the probability of success, the probability a voter would say they would prefer to vote on the internet rather than in person, was 0.39. And here you have a drop-down menu and have 5 options. You want to make sure you pick the correct option. We're interested in the probability that we have exactly 3 voters in our sample that said they would prefer to vote by internet. And so we get a probability of 0.07 to 4 decimal places, 0.0716. Now let's find the probability that less than 3 would do internet voting. So I'm going to do that less than 3. So if I leave this at 3, I'm going to use my drop down to do a less than, strictly less than, and I get 0.0322. I could also do less than or equal to 2, and I would get the same answer. So it would just depend on how you were interested in wording the problem. That would give you the same probability. Find the probability that more than 7. Okay, so notice now x is now 7. But we want to go more than, so I'm going to use my drop-down menu to a greater than 7, and I get 0.1902. And let's see, what's the probability that at least one of the selected likely voters would do internet polling? So at least one would mean what? 1 or more. So I could either do greater than 0 or greater than or equal to 1. Okay, so I get, a pretty high probability. And notice if I change this to greater than 0, I'm going to get the same probability. So again, you can do these 2 different ways. And then finally, what's the probability exactly 12 of those selected would do internet voting? So we're going to have this be equal to 12. Okay, so we get 0.0013. Now, the next question is 12 of the selected voters, 12 of 15, significantly high? High, is it? Why or why not? So remember, in the Triola text that we use in our course, significantly high or significantly low. Significantly high means greater than or equal to that number, and that has to be less than 0.05, and in this case it is. It's 0.0015. So 12 voters would be significantly high number out of the 15 to say they would prefer internet voting.